So I'm Liz. Thanks for coming to my talk. First, a little bit more about me. So currently, I'm at Stitch Fix. I'm on their infrastructure team, and I'm working on our log pipelines. And before that, I was at a startup called Loggly, and I also worked on log pipelines back then. And before that, I was on the newsfeed team at LinkedIn. Cool. So how many here have heard of Stitch Fix? How many here know how Stitch Fix works? OK, so I want to start with that because I'm going to use a few Stitch Fix examples later on. I like to call Stitch Fix the Pandora for clothing. So basically, customers fill out a style profile where they indicate their stylistic preferences, and then we send them a box full of clothes, and they don't have direct input on what they get in their box. We just kind of decide what they get, and then customers keep what they want, and they send back what they don't want. So that's Stitch Fix in a nutshell. OK, back to this slide. So you guys have all been staring at this slide for like the last 10 minutes, and hopefully you're asking yourselves a few questions, like, what does big data mean in this context? Am I just throwing that around like a buzzword? What is this log thing, and what does it have to do with big data? The question you're all hopefully wondering is, why are logs the unsung hero of big data? That's maybe a bit of a bold statement. And if that's true, then how do I get me some logs? How do I get me some logs? Questions. So hopefully by the end of this talk, in 35 minutes, I'll have answered all these questions for you, starting with the easy one: what does big data mean in this context? So I'm not just throwing it around like a buzzword. I actually am talking about something specific, and I want to get that out of the way right now. So I'm not just talking about scale. If you have a petabyte of data in your data warehouse, you're not a big data company. You're a big data company if you're performing analytics on this large data set. So you're actually trying to crunch through all this data and get value from it. OK, so pretty straightforward. You guys are probably know that. Next, what is this log thing? So I want to start by answering this question, in essence, what a log is, and then I'm going to go into a lot more detail later on. But first, I want everyone to think for a second, what do you think a log is? You hear the word log thrown around a lot, and logs have been around for a really long time, like decades. So what do you think it is? OK. I don't mean log files. These are not the unsung hero of big data. These are important, but they're mostly just cumbersome and annoying. I also don't mean a literal log, in case that's what you were thinking. OK, so for dramatic effect, I added a 5-second fade in, which I love. This is what a log is. Wait, OK, one more time. A log is a data model. That's all it is. OK, so what kind of data model is it? A log? Logs are an immutable, append-only data set where each record is an event. What is an event? An event represents some kind of an occurrence. This is hopefully pretty straightforward. An event usually follows the format X did Y at time t. And I have a footnote, because maybe you're wondering, why isn't it just Y happened at time t? And the answer is that X, when you have an X in here, it's really useful for partitioning and joining. I won't go into too much detail about that, But suffice it to say that normally logs have an x did y format. So this is kind of what it would look like. You've got time 1, x did y, time 2, x did z, then foo did bar, then fizz did bar, then fizz did bar again. Just a series of things that happened. Okay, so that is in essence what a log is. I'm going to go into a lot more detail later on when I'm explaining why logs are great, but I'm going to move on to the next half of this question. What do logs have to do with big data? So remember that big data was about performing analytics on large data sets. And you need accurate and well-organized data to perform accurate and valuable analytics. We all know the saying, garbage in, garbage out. If your data is garbage, your analytics are going to be garbage. How do you get high-quality data for your analytics? And the next point, this is important for this talk. Analytics usually means analyzing the past. So not always, but usually, you're looking at what has happened in order to predict what will happen. So what kind of data represents the past? Logs. Logs. So that's what logs have to do with big data. Okay, so I answered the easy questions, the what questions. I'm going to focus the rest of the talk on these harder questions, the why question. Why are logs so great? So I want to illustrate by counterpointing log data with another kind of data model that you're probably more familiar with, which is transaction data. Now, transaction data, also known as state data, also known as operational data. I actually had a debate with my colleagues a few days ago. We were trying to decide what is the correct term for this. And we all found various Wikipedia articles supporting our various positions. So I think the answer is the industry hasn't really converged on a single term for this concept, but the concept is the same. So transaction data represents the state of the world in the present moment. What is true right now? OLTP databases, so online transaction processing databases, are optimized to store this kind of state. This is because they're optimized for many small writes and reads, for concurrent access, for very random specific queries. These databases are really good at handling this kind of data. Examples, MySQL, MongoDB, Postgres, these are typically OLTP databases. OLTP databases answer questions like, how many funds does this client have? How much money does this person have in their bank account right now? What is this user's email address? What email address do we have on file for this person? Is this passenger authorized to fly on this plane? So you go to scan your boarding pass, it's going to some OLTP database somewhere saying yes, no. The data in an OLTP database is mutated as time progresses. So this is really important. Records are being deleted, added, and updated all the time. So compare that to log data. Log data is a ledger of all the things that have happened. With log data, you can answer questions like, how much money does this client usually spend? That's really important for fraud detection. How many orders did we send last year? Something that Stitch Fix usually wants to answer. Which buttons do customers click? Which buttons do customers not click? That's a hard question to answer without log data. Log data is continuously accumulating. It is append only. It's written in stone. This is because you cannot rewrite history. Once something happens, it happened. There's no going back from that. So you need to have log data to record all the things that have happened. Okay, so I'm going to go out on a limb and say that your company has OLTP databases. You have these databases. You can't really do a whole lot without them because they store your customers, they store your inventory, they store all kinds of useful things. So this is maybe what your company looked like when it was starting out. You've got a web app, you've got your DB, you've got your happy customer. So now you want to do analytics on this OLTP database. That database doesn't keep track of what its state used to be. That database, you can't send a query saying, hey, what was your state 2 weeks ago? Like, all it knows is what is true right now in the present moment. So to analyze your data, you need a record of what has happened in the past. OLTP databases don't know what their state used to be, so you need to keep track yourself. You decide to take periodic snapshots and load them into a data warehouse. This should sound pretty familiar because this is the classic ETL pipeline. This has been around for a while now. And it's actually not bad. You've got your database, you've got your snapshots, you can analyze those snapshots, you can actually get pretty far. But ETL Classic is okay, but has drawbacks. So I want to dig into these drawbacks and explain why log data solves those problems. 1, you don't know how the database changed between each snapshot. So I'll use a Stitch Fix example. We have an item DB that tracks all of the items in our physical warehouses, all of the clothing that's sitting on the racks. And we have several warehouses, so we're always tracking what's going in and what's going out. So this is a really simplified view of what that database might look like. We've got the SKU as the ID, and we have a SKU count, the number of the SKU we have in our warehouse. So when someone purchases a shirt, we decrement this number, and that's how we keep track of how many of this shirt we have in the warehouse. Pretty simple. Now, snapshots, if you were to snapshot the item DB, you can't really tell what changed from day to day. This is because your snapshots would look something like this. Today, you know you had 0 of that shirt. Yesterday, you had 0 of that shirt. Last week, you had 35. If you're being really naive, you could say, oh, well, between last week and yesterday, we sold 35 shirts. But in reality, a really popular shirt, we might get a shipment of 1,000. They all go into the warehouse, and by the end of the day, they've all been sold. So yesterday, the count was 0. Today, the count was 0. In reality, that shirt, we sold thousands of that shirt, and that's a really interesting analytical data point that you would not be able to capture with snapshots. How do you solve this problem? So one option, take more snapshots, just more snapshots. That kind of gets the job done, but then you're in a world where you're taking snapshots like once every 5 minutes, and the engineering, the app devs are like, you're taking down our database, stop taking so many snapshots. Another option is join the item DB with other databases, like the shipment database. That's an okay solution. That might kind of get the job done. Make the item DB append only and poll for new records. So instead of decrementing the value, you just create a new record and kind of tombstone the last record. I think OLTP databases, depending on the data set, they're not really designed for that. So I don't think that's really a great option. Or you could use logs. You can use logs. So with logs, how do we solve this problem? A log event gets emitted each time the item database changes. With logs, you can reconstruct the database's state at any point in time. This is really powerful because you can ask questions like, what items did we have in our database in our warehouses 2 hours ago? What items in our warehouses did we have 2 hours ago, 35 minutes, and 27 seconds ago? You know exactly what items were in the warehouse. So I have a footnote to explain where the log event gets emitted to. They get emitted to log pipelines. And I will talk more about log pipelines, but suffice it to say, this is where logs go, log pipelines. So with logs, you've got the same database, you decrement the value, and then you also emit a log event saying this SKU decreased by one amount at this time. See, you've got the XYT format here. Okay, so that's one problem with snapshots. You don't know how they change between each snapshot. You don't know how the database has mutated. 2, you can only analyze data as frequently as snapshots are taken. So this might seem pretty self-explanatory. If you take a snapshot once every 24 hours, you can only analyze that data at worst 24 hours later. But I think there are some subtle benefits to having data flow in real time. So log data flows in real time. This is great because historical analysis and real-time applications can use the same data/infrastructure. So more and more people are building real-time applications to do real-time analytics on this stream of data that's coming in all the time. That stream of data can be archived in your warehouse, and then you can have batch processes that run on the same data. This is really powerful because you can it's much easier to switch between a batch job and a streaming job, and your data just has a uniform view. Logs can be enriched in real time, so you can have an application that consumes all your logs, adds useful metadata, and pushes it back into the log pipeline. PII is stripped before entering the data warehouse. You can have another stage that consumes all the log data and obfuscates or gets rid of all of the PII before it even enters the data warehouse. And corrupt data can be prevented from entering the data warehouse. So if you can validate that the log data looks the way that it should at the time that it's being produced, which is nice because you don't get all this cruft getting into your data warehouse and corrupt data that's hard to deal with later on. Okay, so that's one reason why having data flow in real time. Those are reasons why having data flow in real time are really great. Lastly, and I think this is the real kicker, is that you can only analyze data that exists in the OLTP database when you're taking snapshots. So why is that a bad thing? If transaction data and log data are separate, they can evolve orthogonally. So for example, a user's geolocation is important for analytics, but irrelevant for operational applications. So the web app doesn't need to know what this user's geolocation is. So they're not going to want to store it in their database, but they can emit it in the log events. When application devs need to make database changes, the logs can remain unaffected. So for example, the app devs decide to migrate their database from MySQL to Postgres. As long as they're emitting the log data, analytics doesn't have to even know that they're doing this. Many entire data sets are not useful for operational applications, but are needed for analytics. So this one is huge because there's just troves of data that is never going to get stored in an OLTP database, just never. Like click streams, sensor data, visitor logs. Another great thing when you separate your transactional data from your log data is that log data can be endlessly rich. So log data can capture context around these state changes. So why did something in the OLTP database change? With this context, it's easier to answer questions like why did something happen? For example, at Stitch Fix, a customer can place a shipment from both the web app and a mobile device. The OLTP database does not know where the shipment was placed. It knows the shipment was placed, but it doesn't know where the request came from. But the logs can show you that customers are much more likely to place orders from their mobile devices. Another great thing about log data is that the amount of data you can push to a log pipeline is nearly limitless. This is because log pipelines are designed to be extremely scalable for large amounts of writes. So you might be thinking, gosh, all this log data sounds like so much data. And it's true. It is a lot of data. It is common for sets of logs to be orders of magnitude larger than transactional data sets. So yeah, you're going to have a lot of log data. OK, so I feel like we covered a lot, and there is a lot more to cover, but I only have 35 minutes. So hopefully I've more or less answered some of, hopefully I've begun to convince you that logs are actually really handy and really valuable when you're doing analytics on large data sets. So the last question, how do I get logs? How do I get these log things? They sound so cool. Well, you need a log processing pipeline, also known as a message bus or event bus. So I think message buses and event buses are subtly different things, but if you hear people talk about message bus or event buses, they probably mean a log processing pipeline. So just so you know. Log pipelines transport data in real time and maintain the order of when data was written. Consumers subscribe to a topic. Producers push data to a topic, and data propagates to all subscribed consumers. So this is kind of like a table, like a MySQL table. A topic has a collection of related data, logically related data, such as like the click stream from a certain web app, or like the paths that the workers are walking in our warehouses in Stitch Fix. Log processing pipelines are backed by a message broker technology, such as Kafka, Google PubSub, or AWS Kinesis streams. So if you hear those words being thrown around, this is what they're for. And a message broker is just a database that is optimized for extremely high write and read throughput. I think some people are kind of like mystified, like, what is this log processing pipeline? Like, it sounds like such an interesting new kind of infrastructure. No, it's just a database that's optimized for certain use cases. OK, so that's a log processing pipeline. And you might be thinking to yourself, oh, right. So back to this picture. This is what your company might look like if you had a log pipeline. You've got your web app, you've got your DB, that's not changing, but now you're emitting these log events. They're going through the pipeline. You might have applications that consume all the log data, enrich it, strip the PII, and then ingest them into your data warehouse. They might also ship it to other applications that do streaming analytics or real-time alerting or whatever. But in the end, you get these logs for each day. Looks pretty similar to your database snapshots, but the way the data is being modeled is different. Because now you have logs from April 19th, you have logs from April 20th, so on and so forth. OK, so you might be thinking to yourself, oh, great, another piece of infrastructure to maintain, or to convince my data platform team to build. But log pipelines are incredibly useful. So why are they useful? Because a centralized log pipeline can be used by an entire organization or even across an entire company. Very leverageable piece of infrastructure. 2, a log pipeline greatly simplifies the problem of data integration. So what I mean by that is, how does data get from the applications that produce the log data to the applications that need the log data? This is not something that many companies solve very well. OK, 3, a robust log pipeline enables a slew of event-driven and real-time applications and operations. So with logs flowing in real time, you can do so many things that you couldn't do back in the snapshot world, back with ETL Classic. So without a central log pipeline, your tech stack probably looks something like this. You've got all these applications producing data on the left, you've got all these applications producing data on the right, or consuming data on the right, and without a centralized standard way to get data from A to B, people are gonna just start making their own solutions. They're gonna create their own connectors, they're gonna have their own APIs, they're gonna have a bunch of random scripts, and this can turn into an operational nightmare, and the quality of your data suffers when you don't have an organized way of transporting your data. With a log pipeline, every application needs to only needs to integrate with the pipeline in order to produce and consume log data from across the whole organization. So that's what it might look like in this case. Every application that's producing this data only has to produce it to the pipeline. It is completely, doesn't know who is using the data, who's consuming it, it doesn't care. All the people consuming data, they don't really know where the data comes from, they just know it's flowing through the log pipeline. And all they have to do is hook into the log pipeline. So it's really, really easy. To put it another way, what if every time you wanted to get data, it felt like getting power from here? You just had to walk down to the local power pole, like with your wire, hook it into this mess of wires, and then string it back to your house, and that's how you got power. That's I think this is what it feels like when you don't have a log pipeline. Or do you want getting data to feel like that? You just have an outlet in the wall, you plug your appliance into it, and boom, power. And one last thing that is so great about log pipelines is the data is flowing in real time. So I'll use another Stitch Fix example, which is the style profile. At Stitch Fix, customers fill out these style profiles with stylistic preferences, and our clothing recommendations are based off of that data, partly based off of that data. So there's a problem. If a new customer fills out their profile and immediately orders a shipment, in the ETL classic world, and if we were taking snapshots daily, we couldn't really do this because we can't crunch through the new style profile data until the next day. But with snapshots, with snapshots, this is what the solution, this is what it looks like. You've got your web app, you've got your style DB, you're taking your style DB snapshots, and then a day later you process through the snapshots, and then you generate your featureized style data. And we can only use that a day later at the earliest. With logs, the solution might look something more like this. So the customer fills out their style profile, and a profile updated event gets emitted into the log pipeline. And we have another app that consumes these events and can calculate the features for that customer in real time. So now, as soon as they've updated their profile, we're ready to recommend clothing for them. This is really nice because not only is it faster, it's also a lot more scalable. You don't have to worry about taking snapshots of the entire database every day. Once you start to have a lot of customers, this starts to become pretty cumbersome. So that's yet another reason why log pipelines are really useful. So yeah, that's pretty much why I think logs are the unsung hero of big data. And hopefully I've begun to convince you of that as well. To recap, big data, we basically mean analytics. Analytics needs accurate and high quality data. Also, analytics usually means analyzing the past. What kind of data models the past? Logs. Yay! What is a log? A data model. Log data is an immutable, append-only data set where each record is an event. Log data is different and often more useful than transactional data. Maybe that's a bit of a bold claim, but I do believe that. Distinguishing between your logs and your transactional data allows each data set to evolve orthogonally and unchains your analytical capabilities from the constraints of the OLTP databases. And log data is collected by a log processing pipeline, and log processing pipelines are really useful for a lot of things. So, the end. So find me during office hours. Thanks. Thank you. Find me during office hours and get really cool Stitch Fix socks. We have these like Argyle socks. They're really, really nice. So I'll just be handing them out at office hours. Tweet me at CZBennett or email me at elizabeth.bennett@stitchfix.com. And also the obligatory, we're hiring like crazy. So talk to me if you want to work for Stitch Fix. And questions?
All right, thank you, Liz. We have time for some questions.
Hi, my name is Christoph from Western Union. So one of the interesting things you said was that history cannot be undone.
Yeah.
And in our case, I'm in the fraud division. We have a lot of people whose accounts get hacked and so forth. So, for example, just like somebody gets arrested and convicted for a crime they didn't commit, they have a huge history of things that really shouldn't be attributed to them, and that can have later on consequences in how you treat that account, let's say.
Yeah.
How do you deal with data like that, which inevitably, yes, did happen, but really should not be considered?
So you actually do want to go back and rewrite history because you wrote history wrong in the first place? Yeah, so that's a pretty difficult problem. This is why it's nice to archive all the data, because you can run these batch jobs like that can go in and like fix stuff when stuff breaks. Like stuff will break. In that case, I would almost say it would almost be useful to have a record of the fact that you guys screwed it up in the first place. So you might just want to copy the data and have okay, this is the old log data back when we were wrong. Here's the new log data that it has been corrected. But I don't think that the old log data should really necessarily be like blown away and just gone forever, because you never know what you're going to want to need a year later. You might want to go back and say, hey, you remember that time we screwed up that customer's data? What did we actually screw up about it? And you might want to go back and look at it.
In this case, it's actually not screwed up. It did actually happen. Somebody did take over account, did use it for fraudulent purposes.
Oh, okay. Yeah. Oh, okay. In that case, you want it.
Suffer the consequences of what somebody else did.
Ah, okay. I think in that world, I would see the log data did happen. That customer did do those transactions. Possibly in your materialized view of what is true, what is truth, like the OLTP databases, you know that this customer didn't commit those actions, but they did actually happen with this account. You kind of, I think it's useful to just still, yeah, I don't know. It's pretty use case dependent.
From your model trainings, because that will potentially train wrong. If you've already taken actions based on that incorrect data, then there's that whole history of, oh, we rejected them 5 times in the past. That in itself is a reason for another rejection.
Yeah. I think no matter what, you should keep the original data, because that did happen. That was what happened. And then you might want to have a different materialized view of the cleaned data that you know is actually their transactions. But,
does that not argue for just a separation between the data flows and the application logic? No. And then if you think of the model as a piece of application logic, right? Because you're using it to make decisions. You can decide what pieces of the log are not valid for that application.
Sure, but as I said, I think what maybe becomes the bigger problem is the propagation effect that has already taken place in a lot of cases. That's not part of the log now. That's part of some other transaction history. In our case, on some severe, let's say, criminal cases, we work with the FBI. So, if we see that your account was used to transfer money to some drug mules, you're now on the FBI's whatever list. So, it gets complicated really, really quickly.
Yeah, that's true. I still think the fact remains that that did happen, and then figuring out why it happened is something that is sort of a separate problem.
To his question, yesterday there was a talk about Hoodie, open source library from Uber. They have a similar problem. I think that library was supporting making updates on a large data set. They have two different models, and maybe talk to those people. Hoodie, open source library. Yeah, I think in this case, it does probably help to not remove the log record, but maybe update a column or something to indicate that this was a fraud record. And that library also has provision for triggering something for the derived tables to be updated as well.
Yeah. I think that makes sense. I think the log data is just sort of like the raw data of what we know happened, and then the derived tables you can kind of join when you're doing your analysis, join on the derived tables indicating like this happened, but it didn't really happen, like things like that.
My name is Mark from New Relic. My question is, what in your experience have you found is the ratio between log data that has to be manufactured, it has to be generated especially from the application layer versus just hooking into, say, a MySQL bin log or a web server log file? Like, what do you see as the ratio between those?
Yeah, that's a really good question. So there's kind of two main approaches to collecting log data. You've got the change data capture, where you actually hook into the database itself, and you listen for the changes that happen on the database. And then you've got event sourcing, which is where the application produces those events. And like the application is kind of responsible for creating that stream of log data. I think the change data capture makes sense if you have, let's say, a database and you have a cache. And whenever the database changes, you would need to update whatever's in the cache. Like, they're pretty closely coupled. Like with the change data capture, you still are pretty limited to what the database has. If you're just looking at what records changed, what records were created and deleted, you're still really chained to that, your OLTP database, and you're chained to the semantics of that database. So I think in general, it's actually more freeing and more flexible to produce the events from the applications themselves, because the application logic can add a lot of things. The application logic can just add metadata and useful, like, just all kinds of things that wouldn't necessarily go into the OLTP database. So I think it's a little use case dependent, but for a lot of like historical analytics and things that just kind of you want to have a logical view of what happened, I think it's a little bit more useful to produce the logs from the event, from the application logic. The only downside to that is that it's more error prone. So what if the application forgets to emit a log event? So that's one of those things that you have to really be good about establishing best practices and working with the people who develop the application, and like making sure that they actually have unit tests, making sure that the log event was produced. Like, they have integration tests, and when they're testing new code, they're actually validating the log events are being produced still. So.